Hello, my name is Raymond Phelan. I am a Master's degree student at National College of Ireland. My student number is 17119847. The following project I will be presenting is a proposal for a research topic. The title of this project is An Evaluation of Node.js for Processing Big Data Using Serverless Frameworks for the JavaScript Data Scientist. The research proposal that I am presenting aims to evaluate the performance of Node.js in running common big data MapReduce design patterns on serverless cloud environments. Currently, a number of research papers have been published that have evaluated the performance of serverless environments, measuring startup times using cold startups and warm startups in order to evaluate the actual serverless containers themselves. The research that I am proposing in this project will not evaluate the serverless container, but specifically the performance of Node.js when performing data science using serverless functions and cloud storage. This will provide a baseline for future research. Serverless computing is a cloud computing service that allows developers to simply write functions and deploy them in the cloud, without having to manage the underlying infrastructure for that function. Serverless functions are triggered by events, for example, a put or a get request from an object store. The cloud provider manages the entire infrastructure for the serverless functions, providing the ability for automatic scaling up or scaling down as needed. Serverless functions are billed for the time they are in execution, per 100 milliseconds, as opposed to traditional virtual servers that are normally charged on an hourly basis, whether they are in use or not. With serverless functions, you only pay if the function is in use. If the function is not running, you are not paying. There is much research being carried out on serverless functions, as it is still in its infancy stages. One of the research areas is the possibility of doing big data analytics using serverless functions. Traditional parallel computing using distributed clusters of high-performance computers is expensive and complex, and beyond the reach of many developers. Serverless computing offers an exciting alternative to distributed computing clusters and provides automatic scaling of resources. Since serverless functions can be written in a number of high-level programming languages, such as Node.js, Python, Ruby, Java, Go, C#, and PowerShell, this has opened a pathway for JavaScript developers to enter the world of big data. The first official version of JavaScript was released in 1997, officially known as ECMAScript 1. Since then, JavaScript has come a long way. Currently, JavaScript is on ECMAScript 2018 and provides many advanced features in comparison to the first version, such as asynchronous programming and object-oriented programming. Originally, JavaScript was designed for manipulating static HTML pages and providing interactivity to websites. It was a front-end language with limited usage. With the introduction of Node.js, JavaScript could then be run on a server, meaning JavaScript could also be used as a back-end language. Node.js is an open-source, event-driven, server-side language that uses JavaScript. With Node.js, JavaScript can now be run outside the browser, on the server. Serverless functions can be written in JavaScript using Node.js. With the idea of using serverless functions for big data analytics means that JavaScript can now be considered for data science, since serverless functions can be written with Node.js. There has been some research already done proposing that big data analytics could be done using browsers. Other research points out that browsers are already being used as tools for big data analytics, such as the Jupyter Notebook. There is a sense of JavaScript everywhere, since JavaScript can now be run on the front end, back end, and big data analytics. This should provide many future research opportunities on the topic. The JavaScript scientist. The JavaScript data scientist is a concept that no one could have imagined at the start of the millennium. Emerging technologies such as cloud computing, Node.js, serverless functions have combined their forces and created this new concept of doing data science with JavaScript. A full stack developer could now be considered as being able to do front-end development, back-end development, and data science. This research proposal is intended to provide an evaluation on the performance of Node.js running common big data MapReduce tasks using serverless functions and cloud storage. The objective is to create a baseline for future work and to introduce the concept of the JavaScript data scientist. To perform this evaluation, we will use 3 datasets of completely different sizes, ranging from 100,000 lines up to hundreds of millions of lines. These datasets will be stored using cloud storage. For this experiment, we will be using the top 3 cloud storage providers: Amazon S3, Azure Blob Storage, and Google Cloud Storage. Our serverless functions will be written with Node.js and deployed to the top 3 serverless platforms: AWS Lambda, Azure Functions, and Google Cloud Functions. Our Node.js functions will perform a number of common standard MapReduce patterns, such as summarization patterns, filtering patterns, data organization patterns, meta patterns, and input and output patterns. By using a variation of dataset sizes, combined with the use of multiple cloud storages and multiple cloud serverless platforms, we plan to be able to create a baseline for the performance of Node.js for big data analytics using serverless functions. This baseline can be used for further research on the topic of JavaScript serverless big data. We have introduced the concept of the JavaScript data scientist. The JavaScript everywhere paradigm seems quite appropriate when we consider extending its use into big data analytics. There is no doubt that JavaScript has come a long way since the introduction of the first official version in 1997. We believe there is an exciting future for the JavaScript developers and serverless functions. This concludes the presentation of this project. Thank you for listening.